Hello and welcome to another video. This is a continuation of chapter 3. We were doing chapter 3, we did units, conversions, we were doing estimation. I had um, recorded a video where I was doing estimating to different numbers of significant figures or decimals or whatever the case may have been. Today, the topic is limits of accuracy. Okay, what do I mean by limits of accuracy? You must have done upper bounds and lower bounds earlier on in your classes, and that is what limits of accuracy is about. Let's read out what the screen says. The limits of accuracy are the smallest and largest values a measurement might take and still be within the stated accuracy. A length of cloth, some cloth is measured for a dress. You might say that the length is 145 centimeters to the nearest centimeter. Now you've rounded off to the nearest centimeter. What does that mean? That the actual length of the cloth could be anything from 144.5 to 145.499. Both of those numbers round off to 145. Okay, let's say you had 144.8, you would have rounded off to 145, and then if you know, even if you had 145.1, you would have rounded off to 145 using the normal convention method, which is to round up a figure of 5 or more. Clearly, this is effectively 145.5, and we use upper bound as 145.5. The lower bound is 144.5. What that simply means is that a length of 145 basically has a lower bound of 144.5 and an upper bound of 145.5, which is not included. You can see that. Why? Because that would round off to 146. So the upper bound is always without an equals to sign, and that's how you state it. That's not something that you need to worry about. You state that the upper bound is 145.5. Okay, the upper limit often causes confusion. We use 145.5 as the upper bound simply because it is inconvenient to work with 145.49. Okay. When measuring the length of a page in a book, you might say that the length is 437 millimeters to the nearest millimeter. What that simply means is that 436.5 and 437.5 are your lower bound and upper bound. Okay, in both examples 1 and 2, the measurement expressed to a given unit is in possible error of half a unit. What that simply means is that whatever you are rounding off to is halved and then added or subtracted from this. Okay, how that affects is if you see B, and then I have a general rule for you here. Okay, if your brother was weighed on more sensitive scales and the result was 57.2 kgs, his actual weight could either be 57.15, which rounded off to 57.2, or it could be something less than 57.25, let's say 57.24 or 23, that rounded off to 57.2. Okay, so the decimal place might change. It's not necessary to just add 0.5 and subtract zero point 0.5. You might be asked to add 0.05 or subtract 0.05 for that matter. The upper bound or limit is the highest value, and the lower bound or limit is the lowest value a measurement might take. For a measurement now rounded to the nearest R units, that's important. Lower bound is rounded measurement minus half R, and upper bound is rounded measurement plus half R. Okay, those are important ideas. For example, the diameter of a CD is 12 centimeters to the nearest centimeter. So you see, I've said nearest 1 centimeter. So I've done half of 1, which is 0.5, and I've added 0.5 here and subtracted 0.5. Similarly, the mass of a coin is to the nearest zero point 0.1 kgs. So I've taken half of 0.1, which is 0.05, and I've subtracted 0.05 and added 0.05. Then 330 meters to the nearest 10 meters. Then what I've done is half of 10 is 5, so I've added and subtracted 5. Okay. Copy and complete the table. Let's look at this. Temperatures in a fridge are 2 degrees centigrade to the nearest degree. So I'm first going to do half of 1, which is 0.5. So I'm going to add 0.5 and subtract 0.5 from 2. Mass of an acorn is 2.3 grams to 1 decimal place. So 1 decimal place means 0.1. What is half of 0.1? It's 0.05. So you add 0.05 and you subtract 0.05. 64 meters to the nearest meter, nearest 1 meter basically. So 0.5, 63.5 and 64.5. So I'm taking is 100 meters is 13.6 to the nearest 0.1 second. So half of 0.1 in this case. So 13.55 and 13.6. Okay. In a DIY store, the height of a door is given as 195 centimeters, correct to the nearest 1 centimeter. Write down the upper bound for the height of the door. So you first do half of 1 and you say half of 1 is 0.5. What is the upper bound? Upper bound is measurement plus half of r, which is calculated as 0.5. I have 195. Then in the next question, example number 22 says a surveyor using a laser beam device can measure distances to the nearest zero point 0.1 meters. What is the least possible length of a house? So I'm asking you for the lower bound. So I'll do half of 0.1, which is 0.05. Lower bound is just simply subtraction. 95.6 minus 0.05. Had I added, it would have become 95.65. But since I'm subtracting, it would become 95.55. Okay, the length of a road is 1300 meters, correct to the nearest 100 meters. So half of r is basically half of 100, which is 50. Copy and complete the statement. So I need to state the upper bound and lower bound. So the upper bound is going to be 1350. The lower bound is going to be 1250. 1300 plus half hour and 1300 minus half hour. A metal bar is measured to 10.5 centimeters, correct to the nearest millimeter. Okay. Okay. Now this is a little tricky. This isn't given in centimeters. This is given in millimeters. You need a consistent unit. What I would encourage you to do is, since half of r will just simply be half of 1, this is 0.05 millimeters. Now I have to add 10.5 centimeters and 0.5 millimeters if I want to state what is the least possible measurement. Okay, how do I add these two? Either I convert them to centimeters. Now this is given in centimeters, so what I should do is I should convert this to centimeters as well. If you remember the conversion, 1 centimeter is 10 millimeters. When you're going into a bigger unit, millimeters a smaller unit, centimeters a bigger unit, you divide by 10. So this would become 0.05 centimeters. Remember that I've still done half of 1 because that was nearest millimeter, but then I have had to change the number. So this would be 0.05 centimeters. Then I add 0.05 centimeters. This would become 10.55, and this should be 10.45. That answers all the questions. The upper bound is 10.55, the lowest 10.45. Okay. The length of a rectangular rug is given as 0.9 meters, correct to the nearest 10 centimeters. The width of the rug is given as 0.96 meters, correct to the nearest 10 centimeters. Again, if you see, the r is in 10 centimeters. So half of r would be 5 centimeters, but half of 10 would be 5. But I don't need to add centimeters, I need to add meters. So what is this in meters? I divide by 100. This is 0.05. Okay. Write down the upper bound. So that's of the length of the rug, 0.9 plus 0.0. That's 0.95. Okay. Then write down the lower bound in meters of the perimeter of the rug. Now for the perimeter, if you remember, the perimeter is basically 2L plus W. If it's a rectangular rug, that's what the question is saying. Okay, perimeter simply means adding up all the sides. Now, what if I want the lowest perimeter? What I should do is I should first have the lower bounds of both the length and the width. So what is the lower bound of the length? It's simply 0.85. That is what you've just calculated. So width also has the same ideas. So the lower bound is 0.65. So L plus W, both lower bounds. Let's add these up as first. That gives me 1.5, I think. Or 0.15, it gives me 1.5. Okay, I can add them up manually for you. Because on the exam, that is what you might be asked to do. The 2 times 1.5 is 3. That's 3 meters. Okay, I should probably include some extra space here, but I haven't done that. I'll do that later. Okay, state the limits of accuracy for the following approximation: 735 to the nearest whole number. Nearest whole number means 1. Okay, and it's not stated, it's just simply 1. If I just say nearest millimeter, nearest centimeter, it simply means 1 centimeter, 1 millimeter, and so half of 1 would give me 0.5. 735 plus 0.5, 735 minus 0.5. So that's going to be the lower bound and upper bound. That gives me 735.5 and 734.5. Okay, part B, 23.56 correct to 2 decimal places. What is 2 decimal places? It's 0.01. Okay, so for you first do half of 0.01, you say that this becomes 0. And it's simple. What you simply do is you add a decimal place and say 0.0010. So basically it's 0.010. So half of that would be 0.005. Okay, now I have to add this. This becomes 23.565, and I have to subtract this. So I borrow 5458. So the lower bound is 23.545. A little tricky, and 23.56. Part C, it says length and width, length 130 correct to 2 significant figures. Now, what do I mean by 2 significant figures? I simply mean 2 significant figures as 10. Okay, 10 means 2 significant figures. 1 is significant and the 0 is also significant for me. Okay, or you can simply count the significant figures from here, 1 and 2. Okay, that's how you round it off. Um, no, sorry, you would count. Okay, so for 2 significant figures, you would count from here, 1 and 2. Okay, so that you don't make a mistake later on. Okay, so that's 2 significant figures. So that would be the 10th place. So I'm going to say half of 10 is 5. So that's going to be 135 is going to be the upper bound, and 125 is going to be the lower bound. For 3 significant figures, what you do is you first count the significant figures. So 1, 2, and 3. Okay, so that's the third significant figure. That's simply the units digit. So I'm going to do 130 plus half of 1 and 130 minus half of. Okay, so that's going to be 130.5 and 129. Okay. Okay, example 21 says state the limits of accuracy for the following approximation. In each case, copy and complete the inequalities. This is important. So then there is this is one nearest 1 centimeter. So I'm going to do half of 1, which is 0.5. So let's add and subtract 0.5. So that's going to be 15.5 and 14.5. You might have noticed that I always add first. It's easier to do that, and then I subtract. Okay. So nearest millimeter, so half of 1 gives me 0.5 again, but this is in millimeters. I need to add this to centimeters. So what I'm going to do first is I'm going to change this to centimeters and say that divide by 10 gives me 0.05. Okay, so 23.65 and 23.55. To the nearest 10, so half of 10 is 5. So 3065 and 3055. So three significant figures. Let's count the significant figures first. 1, 2, 3. So the third significant figure is basically point 0.1, the first decimal place. So I do half of 0.1 first, and then I add and subtract this. So 99.75, 99.6. To one decimal place. One decimal place means 0.1. So first half of 0.1, that's 0.05. So 678.95, 678.8. Nearest to one significant figure. What is one significant figure? One significant figure is here. Okay, so that's 10,000. It's been rounded off to 10,000. So you first do half of 10,000, and you say that this would be going to be 5,000, 65,000, and 55,000. So the nearest 100, half of 100, 50, so 350 and 250. The three significant figures, 99.9. Where is the third significant figure? 1, 2, and 3. So that's the first decimal place. So you do half of 0.1 first. Okay, so that's 99.95 and 99.85. Okay, I hope this was clear for everyone. This is the repetition of what I've taught you so far. We haven't done past paper questions as yet. We will now move on to past paper questions where you will be given these as word problems or something like that. Okay, let's see. It says do not use calculator for this question. Okay, so you're supposed to do this without a calculator. It says the mass of a marble is given as 5.4 grams to the nearest tenth of a gram. What is tenth? Tenth is the first decimal place. It's rounded off to nearest 0.1, which is 0.05. Okay, so 5.4 grams, that's the mass of a marble. The mass of a box is given as 85, correct to the nearest 5 grams. So half of 5 is 2.5. Okay, mass of one marble, I want the lower bounds and upper bounds. So I'm first going to add this to 5.4. This is going to become 5.45 and 5. Okay, then 85. So 85 becomes 87.5 or 85, 82.5. Okay, rounded off to the nearest 5 grams. Find the lower bound for the total mass of one of the box and 20 identical marbles. So the box lower bound is 82.5 and 20 marbles at 5.35. I will have to multiply this before I can add it together. So I ignore the decimals. I put a cross for the 0. 2 times 5 is 10. 2 times 3 is 6 and 7. And 5 is 10. And then 2 decimal places. So 107. So 82.5 plus 107. That gives me 189.5. Okay. If you are confused, you just add it up. Okay. 189.5 is your final. The cost of a chair is X, correct to the nearest $10. So what is half of 10? Another past paper question, I think. That's 5. And the cost of a desk is nearest 50. So half of 50. Okay. So 65 and 75 and 925 and 875. So the upper bounds and lower bounds for X and Y. Read the table, that's what I've already done for you. And the lower bound of the total cost of a desk and 4 chairs. So desk is 875, 4 chairs is 4 times 65. 4 times 65 is without a calculator is 4 times 6 is 24 and 26. Okay, so 875 plus 260. 1135. Okay, then if p equals to 7 and q equals to 5, correct to the nearest centimeter, find the largest possible value of p plus q. Okay, So in this case, what you should do is you should draw these tables. Let's first write the upper bounds and lower bounds of P and Q. Okay, I'm going to write P here, lower bound here, upper bound here, lower bound here, upper bound here. Okay, now I think I should first calculate the lower bounds and upper bounds first. Let's make a different table like there was one in before. Okay, so let's write that down. Lower bound, upper bound. So nearest centimeters, it's going to be 6.5 and 7.5 and 4.5 and 5.5. Okay, now there are four combinations of these. I think my screen is stuck. I don't know why that might be. Okay, I think you now see the table and the screen as well. Okay, now whenever you have these addition or multiplication or subtractions, what you should do is you should have a table for each of these. So P plus Q, you see I want the largest possible value and the smallest possible value as well. It's never wise to, just dive into it without having a strategy. Okay, so I've written both values of Q and both values of P. What I'm going to do is I'm going to add them up. So 6.5 plus 4.5 gives me 11. 7.5 plus 4.5 gives me 12. 6.5 plus 5.5, you would probably have a calculator on this one on the exam. So 12, and this becomes 13. So what is the largest possible value of Q? That's 13. P plus Q. What's the lowest possible value? That's 11. Now I should have a similar table for P minus Q. Okay, these are the values of P, these are the values of Q. Let's subtract. 6.5 minus 4.5 is 2. 7.5 minus 4.5 is 3. That's 1. And that's 2 again. Okay, so you see I use the lower bound of, I want the largest value. So what's the largest value? Let's say. So I use the upper bound for P and the lower bound for Q. Okay, so that's 4.5. Okay, then the last part says P square over Q. That's P, that's Q. Again, let's write those numbers down. 6.5, 7.5, 4.5 and 5.5. Okay, for this I think I'm also going to need a calculator. Let me get my calculator. Okay, so what I need to do is 6.5 squared divided by 4.5. That gives me 9.4. 7.5 squared divided by 4.5, that gives me 12.5. 6.5 squared divided by 5.5, and that's obvious. Those numbers are going to be smaller because my numerator is shrinking. Okay. One obvious thing that you need to note here is that since you want the largest possible value of a fraction, the numerator must be the largest and the denominator must be the smallest, which is why this number gives you the largest possible value of P square over Q. That's 12.5. You would be allowed to calculate on this part of the exam, of course. This is not a past paper question. This is from a book. Okay. Then you have a past paper question from the IGCSE exam. Back then it wasn't a no calculator exam, but we'll try to do it without a calculator. This is a square has sides of length t centimeters. The length is 120 meters, correct to the nearest 10 meters. So half of 10 is 5. 125 and 115. Okay. It says calculate the difference between the largest and smallest possible areas of the square. So square is just simply side squared. So either it's 115 square or 125 squared? It's 15625, 13225. Okay, so subtract 15625 minus 13225. 2400. Okay. See how many more questions we have to go. I think we'll be done in a bit. Let's quickly do these questions. A rectangle has sides of length 6.1 and 8.1. Correct to the nearest one decimal place. So let's first adjust our R. So that's 0.05. Calculate the upper bound for the area of the rectangle as accurately as possible. So when you want the upper bound of the area of the rectangle, then obviously your length also has to be the greatest and your width also has to be the greatest. So 6.15 for the upper bound of the length, and then the width, which is also 8.15. Let's multiply these together because this can't be done without a calculator. And what I'm getting is 50.1225. Okay. Okay. Then paper one, so no calculators. The rectangle top is 100 centimeters and 75 centimeters wide. Both lengths are correct to the nearest 5 centimeters. So half of 5 is 2.5. That's what I do always quickly. Find the least possible perimeter of the table. So it's going to be 2L plus W again, 100 and 2.5 and 77.5. 2 times 180, 360. Okay. Then the area of a rectangular room is 22 meters square, correct to the nearest square meter. Okay. The width is 3 meters, correct to the nearest meter. Find the greatest possible length of the room. Okay. If what I want is the greatest possible length of the room, what I will have to do is first calculate the upper bounds and lower bounds. I'm going to say half of 1 is 0.5. So either this could be 22.5 upper bound for the area or 21.5 lower bound for the area. Which one should I use? I want to find the greatest possible length. It makes sense to use the greatest possible area, and that's 22.5. Okay. The width is 3 centimeters, correct to the nearest meter. Let's correct that too. Half of 1 is again 0.5. So either 2.5 and 3.5. If my area is fixed now and I want my length to be greatest, what width should I use? Should I use 2.5 or 3.5? The simple idea is because my area is fixed and I want length to be the greatest, I should use the smallest possible width. Okay, I could also make something like uh, a table for you and say that length into width is basically 22.5. I could try out both. I could also try out both areas as well, but it's unnecessary, too many calculations. So I'm going to use the width as 2.5. Why? Because I want the length to be the greatest, which is why I've kept the area to be the greatest. Okay, divide by 2.5. Now this is an easy division. This is just the table of 2.5. Remember that. You can remove the decimals if you want. They will both generate tens and tens. Okay, and then you can divide by 5 or you can directly divide by 25. 25 times 1 and 25 times 9. So the greatest possible length of the room is 9 meters. Okay. In example 34, again a paper 1 question. The last one was a paper 1 question, slightly more calculations. So you'd probably have more marks on this as well. Okay. Example 34. From this paper, pencils are packed in a box. Each pencil has a diameter of 7 millimeters, correct to the nearest. So let's just quickly do that. 6.5 millimeters is the lower bound, and 7.5 millimeters is the upper bound. Write down the lower bound of the diameter of a pen. The diameter is the lower bound is I've just written, I've done half of 1 and I've added this and subtracted it. Find the smallest possible width of the box that can hold 8 pencils side by side. I want this to be smallest, and I want the pencils to be smallest as well. Okay, so 8 pencils and the smallest diameter. Okay, what should that give me? Let's multiply. I don't know directly. 8 times 5 is 40, 8 times 6 is 48, and then 52, then one decimal place. So that's 52 millimeters. I want France in centimeters. You divide by 10 and you say 5.2. Okay. Okay. I think this is from another topic. That's the end of the chapter. I will see you with another video in the next class. Now we are going to start a different chapter. I'm also going to do some exercises on this later on, and you can see the marathon, do some more questions. This is a tricky topic. It's not an easy one. It takes time to digest what I've just taught you. Thank you for watching.